Go over each of these questions that are going to be on your assessment as a review, and I will go over the first or one of the exceeding questions. So for this one, remember, if you get stuck, take the numbers and separate them from the variables. So I'm going to rewrite this as 5 cubed times x to the 9th raised to the 3rd power, because this is where you're making your mistake. You're not treating your coefficient or the numbers like numbers. You're applying the power rule to them when they're not being raised to a power. So this cube gets distributed, if you want to think of it like that, to both the 5 and the x to the 9th. Well, 5 cubed is 5 times 5 times 5, or 125. And now our rule when when we are raising a power to a power is we multiply, because this would eventually be repeated addition of x to the 9th times x to the 9th times x to the 9th. So we will be adding these 3 times, or instead of having to expand out and add, we know that that is going to be repeated addition. So we just multiply, and that gives me x to the 27th power. All right, so same thing when you go to do number 2. We can just take our coefficients and just treat them as their own numbers, as if I just gave you negative 6 times 9. And negative 6 times 9 is negative 54. Then we can take our exponents and we can then look to see, well, what are we doing with those? So it's x to the 13th times x to the negative 5th. When we're multiplying, we add, so it becomes 13 plus negative 5, or that's the same as 13 minus 5, which is then 8. So it becomes x to the 8th power. All right, so same thing here. I'm going to take my numbers, my coefficients, and I'm just going to just write them all to the side and say, if I gave you a fraction 6 over 16, how would that simplify? Well, both of those are divisible by 2, so that simplifies to be 3 over 8. So I know that my numbers are going to at least be 3 over 8. Then I look at my variables and I say, okay, I have a to the 18th over a to the 25th. So remember, I'm saying, where do I have more? Because where I have more is where my a's are going to end. So I have more a's in my denominator, so I'm going to write a down in my denominator because I know it's going to end there. And if I did 1 minus 4 or 4 minus 1, it gives me the same number, but different signs. So that's why we ask ourselves, where is there more at? Because technically the rule is you're supposed to subtract the numerator or the denominator from the numerator and then make that negative exponent positive by flipping it. But I've learned that students make some mistakes with that. So by saying where is there more and writing that, and then taking wherever there's more and subtracting the less, so 25 minus 18 is 7, I don't have to worry about flipping any negatives because it's already doing that in the step. Since we saw that 1 minus 4 was negative 3 and 4 minus 1 was 3, we see that that's taking in consideration that negative by just simply asking where is there more. All right, so then for this number 4, we can't have any negative exponents. So then from here I look and say, okay, I have a negative exponent of x to the negative 6. It is not written in parentheses. If it was written in parentheses like this, and that means that 12 is also being raised to negative 6, but when it's written like this, only the thing next to it is getting raised at negative 6, so it's only x to the negative 6. So when I want to make it positive, I just change its spot in the fraction. If it's in the numerator, it drops to the denominator. If it's a denominator, it moves up to the numerator. So that means only the x is going to move up. I can write 1x, and then that changes it to be positive. By moving it, we're changing that sign of that power. So it's 1x to the 6 power over 12, or you don't have to write the 1 in front, because when we have just x to the 6, it's implied that that is a 1 in front of it. All right, so then it's number 5. Here, the only thing being raised to the 0 power is the x. And remember, anything raised to the 0 power is 1. We learned that by going over the 4 to... by going over 8, 4, 2, where this is written as a power of 1, this is written as 2 squared, this is written as 2 cubed, and our pattern that we're doing is we're dividing each of these by 2 to get to a number smaller than it, and we're subtracting 1 from the power each time. So if we continue that pattern and we divide by 2, we get 1, and that means we have to subtract 1, which then gives us 2 to the 0 power. So that's showing us that anything raised to the 0 power is 1. Well, here the only thing being raised to 0 power is the x, so it becomes 18. Here, this entire 2x to the 5th is being raised to 0 power, so this entire parentheses is going to change to be 1. However, it's being multiplied by that negative 3. So it becomes 18 minus 3, which is 15, and then we still have that plus 12 at the end, so it is then going to be equal to 27. Okay, now these ones get a little bit harder because now we're adding a few things in it. So we had that power of 2. So remember, I'm going to separate these from my coefficients, so negative 8 squared, and then my variables, x to the 9th, y to the 12th squared. Well, negative 8 squared is negative 8 times negative 8, which then turns to positive 64. And our rule with power to a power is we multiply. So 9 times 2 is 18, and 12 times 2 is 24. So this becomes 64 x to the 18th y to the 24. This next one, number 7, you can do this a few different ways. You can simplify what's on the inside first, or I'm going to just flip this and get rid of this negative. So since I'm focusing on this negative 4, I'm taking the reciprocal. So when it was just 1 over 12x to the negative 6, we were only moving one thing. So only one thing changed, and it's only the x. So we took the reciprocal of that x, and since it's in the denominator, it moved to the numerator. Here, we're taking the reciprocal of everything that's being raised at negative 4, so that means everything on the inside needs to flip. And when we flip it, it remains exactly like it is because we're only changing this negative. We're taking the reciprocal of that negative, and we're only affecting that. So yes, everything has changed its spot. However, it changed because we changed that negative 4 power. Then I'm going to simplify what's on the inside. So I'm going to do my 3 and 2. This is being raised to the 4th power. Actually, let's do that last because I'm going to simplify everything on the inside. So now we have 3 over 2. I have more x's in my denominator, so I'm going to write x there. 7 minus 4 is going to give me 3. I have more y's in my numerator, so I know y is going to end up there. And 21 minus 16 is 5, so it's going to be y to the 5th. And now I just am going to raise everything to that 4th power, so it becomes 3 to the 4th power over 2 to the 4th power, which I know is then going to give me 81 over 16, and you're allowed to use a calculator. And then we multiply, so it becomes y to the 20th and x to the 12th. All right, so for this one, number 8, once again, I'm going to focus on the likes with my likes, so that means my coefficients. So negative 12 times 3 is going to give me negative 36. And now I'm just going to go and do each one of my variables. Well, when we multiply, we add. So 8 plus negative 5 is the same as 8 minus 5, so now I have x cubed. Here we have y to the 12th plus 10, so it's going to give me y to the 22. And here I have negative 4 plus negative 5, which is then going to give me negative 9, so z to the negative 9. However, we're not allowed to have negative exponents. So I need to continue with this one. And since it wasn't written as a fraction, I'm not asking where is there more at. Just z is raised to negative power, so z needs to change its location, so I'm going to drop it. So now it gets negative 36, x cubed, y to the 22nd. None of those change because none of those were being raised to a negative power. Only z is. So I need to take the reciprocal of just z. So since it was in the numerator, it drops to the denominator. And by dropping it and changing its location, taking its reciprocal, it makes it positive. All right, so then number 9, once again, I'm going to focus on just my numbers first. So 20 over 5 is equal to 4. So right now I know I just have 4. Then I ask myself, where is there more a's at? Well, a positive number is always greater than a negative, so I know that there's going to be more in my numerator. And then it's 7 minus negative 3, which then turns to plus, which is 10. Then I have more b's in my numerator, so it's going to be b, and 12 minus 7 is 5, so b to the 5th power. And here I have more c's in my denominator, so I'm going to put it over c, and 19 minus 5 is equal to 14, so it becomes c to the 14th power. All right, I'm going to do number 1, and then after this, I will not do that number 2 for the exceeding. All right, so for this one, I can't multiply this x to negative 2 and this x to 7 yet because these are being raised to a power. So the first thing I have to do is I have to do the powers because in PEMDAS, exponents come first before multiplying. Yes, there's parentheses, but there's nothing inside the parentheses we can actually do. And that parentheses here actually just mean multiplying. So we need to get rid of our exponent first. So I'm going to distribute this in, and that gives me 2 cubed is equal to 8. And now we know our power to a power we multiply, so it becomes x to the 21st and y to the 9th. Here I will square everything, so 5 squared gives me 25. And then negative 2 times 2 gives me negative 4. And 6 times 2 gives me 12. What some of you did on your test is you changed that to a positive 4 because you're thinking of it as a negative 2 squared. But our rule is we multiply. So it's not squaring that negative 2 to give me negative 2 times negative 2. It's negative 2 times 2, which is negative 4. And then it's all over top of 60, x to the 17th, y to the 28th. And then from here, it's however you want to do it. I personally will multiply my numerators first. So 8 times 25 is going, or you can simplify your fractions first. If you just did 8 times 25 over 60, well, I know 5 goes into 25 5 times, and 5 goes into 60 12 times. 4 goes into 8 twice, and 4 goes into 12 3 times. So I can simplify my numbers first or at the end. It's really up to you. But 2 times 5 is then going to give me 10, and I'll have 3 in my denominator. So I know it's going to be that. Now, when I'm multiplying my x's, I add. So 21 plus negative 4 is the same as 21 minus 4. So it becomes x to the 17th. And 9 plus 12 is 21. So it becomes y to the 21 over top of x to the 17th and y to the 28th. Once again, I'm going to now simplify this because we're not done. I have multiple x's and multiple y's, so I need to make sure I'm applying all the rules. So 10 over 3 won't change. Well, I have x to the 17th over x to the 17th. It's the same amount. And 17 minus 17 is equal to 0, and anything raised to 0 is equal to 1. So that means that they're going to cancel out completely. I don't need to do anything with it. There's more y's in my denominator, so I write it down there. And 28 minus 21 is equal to 7. So it becomes y to the 7th. All right, that is it for this video.